Hello, and thank you for coming to our talk on tripolar electrodes to extract gamma activity in a brain-computer interface. Site-specific noise reduction stands to be a valuable tool for a variety of special populations and experimental environments. For instance, many of our data is collected in labs, and already there are difficulties in processing this in terms of noise. That only becomes greater when you go into people's homes or you go into medical facilities. Much of this research is, especially for spalling interfaces, is aimed for those populations. Tripolar electrodes specifically act as high-pass spatial filters and increase the spatial selectivity of the activity recorded when compared to conventional EEG electrodes. This increases signal-to-noise ratio of the acquired signal. The goal of this pilot study was to determine if tripolar electrodes could be used to detect gamma activity related to the BCI task. To do this, we recruited 2 participants who completed 2 BCI calibration tasks. These tasks consisted of 100 inquiries of 10 stimuli each, 1 target stimuli and 9 non-target stimuli. The 2 conditions completed were eyes open, eyes closed, attend, and not attend. And eyes open, eyes closed, the first half, the participant was instructed to keep their eyes open, and the second half, after 50 inquiries, the participant was asked to close their eyes. Only the first half of this data was used for the analysis when the eyes were open. Similarly, for the attend condition, only the first half, when the participant was attending, did we use their data for this particular analysis. To record this, we used BCI Pi, an open source brain-computer interface repository available on GitHub, and a P300 speller system, more specifically RSVP keyboard. This was recorded with a V amplifier from Brain Products, sampled at 250 Hertz. Our measures of interest were using power spectral density, looking at low and high gamma bands in both the tripolar and conventional EEG electrodes. We calculated power spectral density using Welch's method. Using a two-tailed paired t-test, in the low gamma range from 40 to 50 Hertz, we observed no significant changes in gamma in the conventional EEG electrodes for targets or non-targets. We observed no significant changes in gamma in the tripolar electrodes as well for non-targets. However, we did observe significant changes from the pre-stimulus interval to a later post-stimulus interval in the tripolar CPZ channel in the target condition. In the high gamma range, 50 to 70, no significant changes in either channel type were observed. Looking to the left of this slide, you can see figures 1 and 2. Figure 1 displays participant 1 and 2 target, non-target heat maps. The center of each of these figures is the 0 point. To the left is 1 second pre-stimulus, to the right is 1 second post-stimulus. And as you can see, in the target condition, there is a difference in activation from pre-stimulus to post-stimulus. That's further observable in figure 2, where each of these channels are broken up into 5 different intervals. Starting with CZ tripolar on the bottom left, I've numbered them 1 through 5, 1 being the pre-stimulus 250 milliseconds to 0, 2 being 0 to 250, 250 to 500 for 3, and so on, as you can see in the figure legend. And here you can see as well the significant interval, which is a later 750 to 1000 milliseconds. And there is an asterisk denoting it. But in general, you can see, at least for this target condition, there is a trend towards desynchronization of gamma in in these channels, even in the conventional EEG electrodes, however insignificant. All right, so gamma changes are observable and significant in tripolar channels, specifically in R2 participants in CPZ. There is some difficulty in acquiring and processing this signal, particularly when you have both tripolar and EEG signals in the same recording. There is increased gain in relation to standard channels in the tripolars, meaning they will require um, some special treatment in order to process this data. The supported interfaces currently are older, so the V amplifier is not a commercially available amplifier, although available from Brain products, or unstable. We had tried using a G-Tech interface and uh, unfortunately experienced too much noise coming from the external environment in order to process that. We were successful with the VM, but it did take some time to interface. Um, that said, more data in general is needed to make any conclusions. There's were two participants, and that said, it seems like a promising direction to improve classification in our BCI systems, and further exploration is needed. Thank you.